Balloons released 4 times daily from the Geophysical Observatory at Castlereagh, County Kerry, play an important part in providing people of the nation with an accurate forecast of weather conditions. The principal basis of weather forecasting is having information on pressure, temperature and humidity in the upper atmosphere, and this is the function of the balloon, or rather the equipment that the balloon lifts 16 miles up into the sky over County Kerry. Mr. Sean McWilliams, officer in charge of the observatory at Castlereagh, puts us into the picture about the radio sonde can, as the balloon and radio combination is properly called.
The balloon is filled with hydrogen. It's made of rubber, very best quality rubber. It's filled with hydrogen, and the amount of hydrogen that we put into it controls the rate at which the balloon will rise. The normal rate...
What is the rate of ascent?
The normal rate is between 1,300 and 1,500 feet per minute, and but sometimes we'll get that with a relatively small amount of hydrogen. At other times, depending on atmospheric conditions, we have to put in more to get the same rate. We can't really fix it very accurately, but approximately between 1,300 and 1,500 will be sufficient.
And what goes up with the balloon?
Well, we have the principal item of equipment that goes up with the balloon is the radio transmitter. I have one of them here in my hand, which will probably give you an idea of what it's all about. It's a complete, fully fledged 3-valve radio transmitter. And
what is the function of it?
The function of it is to measure pressure, temperature and humidity in the upper atmosphere. We have 3 elements here. One of them is a small aneroid pressure element, which will measure the pressure. And as the aneroid pressure element changes, it changes the value of an electrical inductance, which will alter the frequency of the signal given out by the transmitter.
Yes.
So that as the pressure changes, the frequency of the signal of the transmitter will change. Similarly, with the temperature, we have a small violet metallic spiral here, which will vary with the temperature, and we'll get then the signal varying with the temperature.
Yes. What is the third element here for?
This one is for humidity. It consists of a little piece of gold beater skin here, which is taken from the inside of an Australian cow, and it possesses the same property as the human hair. It expands or contracts with varying moisture content, but is unaffected by pressure, temperature or humidity.
And the windmill here?
Well, we have the 3 signals, so it's naturally it's no good in having them all coming in together. The windmill operates a 3-point switch, so that the signals are brought into circuit in rotation. First to pressure, next temperature and next humidity, and so on as the transmitter ascends up into the atmosphere.
Well, does this balloon disappear into space?
Oh yes, it travels up, and as it's travelling upwards, naturally the pressure is decreasing, and as the pressure decreases, the balloon is expanding. It will reach the limit of expansion of the rubber, and the balloon will burst, and at that stage the parachute takes over and brings the whole lot of equipment down to earth again.
But can this be a hazard when it's coming down to earth?
Oh, very small, but kind of only a small number. This is the only station in this country sending these up. We've only the one. So the hazard would be small, as long as it's kept away from airports. You couldn't have them going up around airports, naturally.
Where are they likely to be found?
Anywhere within our limit of probably about 150 to 2 miles radius from here. The distance that they travel depends, of course, upon the wind speed, and the direction they travel depends upon the wind direction.
And what is the return rate like? You do get
we
some
get
back.
we get about 50% of them back. We have a label attached to the transmitter asking the finder to let us know, and when we hear from them, we send them out a box. They send the instrument back to us, and we give them 10 shillings reward and pay their expenses for sending it back.
And how is the information received here in Castlereagh?
From the transmitter sending out signals, and of course in the main building we have receiving equipment receiving those signals and measuring the frequency. Once the frequency is measured, it's only a matter of converting from frequency back to pressure, temperature and humidity, as the case may be.
Can we see or hear the signals coming back?
Oh yes, we can both see the equipment in operation and hear the 3 signals.
Can we have a look at it?
Yes, so we'd like to go up now to the main building. You can hear the signals coming in here now. They're being received by this shortwave receiver operating on the 10-metre band. and the frequency of the three signals is being counted by the equipment and plotted automatically on this chart here. If you have a good ear for music, I'm sure you can hear the three different beats, the frequency of the three signals.
Yes. Well, I can notice one different sound anyway.
Yes. Well, the signals, the frequency is plotted on this sheet here, and this man is drawn up as a graph, and the frequency will be converted into pressure on the one hand, and the temperature and also humidity. Before the transmitters go up at all, they are calibrated so that we have three graphs of pressure versus frequency, temperature versus frequency, and humidity versus frequency. So it's only a matter of converting from the frequencies to the pressure, temperature, and humidity.
But how does the information that you get here fit into the general weather forecast picture?
Well, the information here supplements the information that is got from all the surface stations all over the world. The information in the upper air, of course, is much more valuable than the surface information,
yes,
because the air in the upper levels is unaffected by the surface friction. At the surface you have surface friction and various local and topographical influences, whereas in the upper air you're free from all that, and you have a chance of getting the true values of the air temperature, pressure and humidity.
But where do you send your information to from here?
We send it direct to Shannon normally by fixed time telephone call, occasionally by teleprinter, telex rather, and Shannon distributed to Bracknell in England, and by teleprinter link up, and Bracknell distributed to Europe, and it's broadcast for general world consumption.